stuck into two different days, focusing on polynomial division, the remainder theorem, and the factor theorem. If we're going to continue to draw and sketch polynomials, not everything is going to be easily factorable for us. So we need to know how we can factor and make a smaller polynomial written in its fully factored form so that we can identify all of the x values. To do that, we're going to use a couple of different polynomial division rules along with the remainder theorem and the factor theorem to help us do that. Our first task for this lesson is going to be factoring using long division. And we're going to use long division, and then I'm going to show you a slightly easier way using synthetic division. Our next lesson will focus on the remainder theorem and the factor theorem. So let's jump into it. In order to factor using the long division, we need to make sure our polynomials are written in descending order and that all of powers of the variables are present. And be extremely careful with the subtraction step. If not all the powers of the variable are present, we'll need to add them in, and I'll show you how to do that when we get to an example. Our first example is x squared plus 6x plus 10. The first thing I'm going to do is write the x squared plus 6x plus 10 on the inside, and we're going to divide that by x plus 3. And I'm going to start with my x value and say, what times x will give me x squared? We know x times x will give us x squared. It doesn't matter along the top, place value is not a thing when we're dividing using polynomials. So anywhere on top is okay. I now am going to take x and multiply it by everything on the left-hand side. X times x is x squared, and x times 3 is 3x. Now I need to subtract, so I need to change my sign since I'm subtracting everything. When I subtract, we'll notice my x squareds disappear, and I have 6x minus 3x, which is 3x, and then I'll bring down my 10. And then I start again. What can I multiply x by so that I get 3x? Well, that would be a positive 3. So I'll put positive 3 up top and then multiply by everything on the left. 3 times x is 3x, and 3 times 3 is 9. We're going to subtract, so we'll end up changing our signs. When I subtract, 3 x's disappear, and 10 minus 9 is 1. We have a remainder here of 1, so we know it doesn't go in evenly, but we sure have divided. X plus 3 remainder 1 is the solution. When I look at 6x to the 4th minus x cubed minus 2x squared minus 7x minus 19, I see that it is written in descending order, and when I look at my powers, they go from the 4th power, 3rd power, 2nd power, 1st power, and no power. So they're in descending order, and I'm not missing any. Now I want to divide that by 2x minus 3. 2x minus 3 will go on the outside, and then all the other pieces will go on the inside. And we'll start our process. I have 2x. What can I multiply 2x by so that I get 6x to the 4th? I can multiply 2x by 3 to get 6, and I need x cubed so that I can reach x to the 4th. I'll now multiply everything on the left with my 3x cubed. 3x cubed times 2x gives us 6x to the 4th. 3x cubed times negative 3 is negative 9x cubed. We'll now change our signs. This turns to negative, but our negative will turn to a positive since we're changing our signs through subtraction. 6x to the 4th simplifies, and negative x cubed plus 9x cubed will now have 8x cubed. We'll bring down our negative 2x squared, and we could continue bringing all of them down or just one at a time, whatever you're most comfortable with. And I start again. I have 2x. What can I multiply 2x by so that we get 8x cubed? 2 times positive 4 will give me positive 8. And then I have 1x, but we need 2 more so that I can get a cubed. And then we'll multiply. 4x squared times 2x is 8x cubed. 4x squared times negative 3 is negative 12x squared. We'll change our signs. This turns to a negative, and since this is a negative, we'll turn to a positive. Our 8x cubes disappear, and I now have 10x squared, bringing down negative 7x and negative 19. And we start again. I have 2x. What can I multiply 2x by such that I get 10x squared? Well, 2 times positive 5 will give me 10, and we need 1 more x to reach x squared. And then we'll multiply by everything on the left. 5x times 2x is 10x squared. 5x times negative 3 is negative 15x. We'll change our signs, so this turns to a negative and this will turn to a positive. Our 10x squares cancel, and negative 7x plus 15x gives us 8x minus 19. And another time, we got to keep going. 2x times what gives us 8x? 2x times a positive 4 would give us 8x, and when we multiply that by everything on the left, we'll have 8x minus 12. Change our signs. Our 8x's will cancel, and negative 19 plus 12 is 7. It does not go in evenly since we have a remainder, but we can just put remainder 7 for our solution. We want to determine if x plus 1 and x minus 3 are factors of x cubed plus 2x squared minus 5x minus 6. So the first thing we'll do is, if it's a factor, it will divide out evenly. Let's start with x plus 1. Our first divisor is x plus 1. I have x cubed plus 2x squared minus 5x minus 6. It's written in descending order. I have cubed, squared, first power, and then no powers, so I'm not missing any powers along the way. I have x. What can I multiply x by so that I get x cubed? Well, I would need 2 more x's, so I have x squared that we're going to multiply everything on the left by. X squared times x is x cubed. X squared times 1 is positive x squared. We'll go ahead and change our signs because we are subtracting. X cubed disappears, and now I have x squared minus 5x minus 6. And we start again. X times what will give us x squared? Here we'll have a positive x. Positive x times x is x squared, and x times 1 is 1x. We'll subtract, so we'll change our signs. X squareds disappear. Negative 5x minus x is negative 6x minus 6. I have x. What can I multiply x by so that I get negative 6x? Well, x times negative 6 would give us negative 6x. Again, multiply everything. I'll have negative 6x minus 6. Change our signs. This will turn to positive. Positive because we're subtracting. And everything cancels. So this is our first example where we have no remainder. Since there is no remainder, we know it goes in there evenly. So x plus 1 is a factor. And now we can consider x squared plus x minus 6 the reduced polynomial. So this would be like saying x plus 1 times x squared plus x minus 6. If I were to multiply these together and using distribution, we would get back where we started. So the x squared plus x minus 6 is our reduced polynomial. And as we go along here and we reduce our polynomial more and more, this will get easier and easier for us, if you will. We still have to check if x minus 3 is a factor. All right, we'll start back where we began. We have x minus 3 with x cubed plus 2x squared minus 5x minus 6. It's the same setup already. We just have to look at x minus 3 instead of the x plus 1. I have x. I need to make x cubed, so I'll multiply by x squared and then distribute everything on the left. X squared times x is x cubed, and x squared times negative 3 is negative 3x squared. Changing our signs. Our x cubes disappear. I now have 5x squared minus 5x minus 6. What can I multiply x by such that I get 5x squared? Positive 5x will do, and we'll multiply everything on the left. 5x times x would give us 5x squared, and 5x times negative 3 is negative 15x. Subtract, so we'll change our signs. Our x squareds disappear. I now have 10x minus 6. I have x. What can I multiply x by so that I get 10x? Positive 10. Multiplying everything, 10 times x is 10x. 10 times negative 3 is negative 30. We will change our signs because we are subtracting. Our 10x's disappear, but I now have 24 as my remainder. So since the remainder is 24, it's not evenly goes into it because we have a remainder. So x minus 3 we know is not a factor of that polynomial. Okay. Another way to divide is using synthetic division. We want to make sure, again, that everything is written in descending order, and if there's any missing pieces, we need to include that missing piece. So here's our first example of what that might look like. Here I have 2x cubed plus 7x minus 5. Notice I'm missing the x value here, x to the first power. I'm going to rewrite our polynomial then as 2x cubed plus 7x squared plus 0x minus 5, so that it's written in descending order and I have all of the pieces that are there. To write in perform synthetic division, I'm going to draw a vertical line. On the right side, I'm going to pull down the coefficients of each of the values. On the left-hand side, because we are subtracting with long division, that's ideally taking the opposite sign with which we have. So when I have x plus 3, I'm going to use the opposite sign, and I'm going to put that on the outside. To perform synthetic division, you always bring the first term down. Always bring that first number down. Then I'm going to take negative 3 times 2, which is negative 6, and put that under 7. 7 minus 6 gives me 1. And I'm going to repeat. Negative 3 times 1 is negative 3. 0 minus 3 is still negative 3. And one more time. Negative 3 times negative 3 is positive 9. And negative 5 plus 9 is 4. This last number will always be your remainder. If there is a number there, a remainder. And these are going to now be your coefficients of your reduced polynomial. And here we'll have 0, x, x squared. So in order of the values of x, we'll have 2x squared plus 1x minus 3, remainder 4. Since x plus 3 does not evenly divide, it is not a factor of that polynomial. Let's try another example using synthetic division. Here we have 2x cubed plus 3x squared minus 3x plus 4, all divided by x plus 2. It's already written in descending order. I am not missing any x values on my step. I have cubed, squared, first power, and then no powers. I'll pull the coefficients 2, 3, -3, and 4. I'm going to use the opposite sign I see here. That will help take care of that subtraction when we are using long division. We always bring down the first term to start us off, and then we can begin multiplying. -2 times 2 is 4, -4, so we bring that up top. 3 minus 4 is -1. -2 times -1 is +2. -3 plus 2 is -1. -2 times -1 is +2. And 4 plus 2 is 6. Here is our remainder. We'll have no x's, x, x squared, and we would keep building the x's as long as we go, but this is our reduced polynomial. So our quotient is 2x squared minus 1x minus 1 with a remainder of 6. And finally, one last example. I have -x cubed plus 5x minus 7 divided by x minus 2. Notice I'm missing the x squared value. So when I write this in to use the synthetic division, I will have -1x cubed, 0x squareds, 5x minus 7. Using our opposite sign, because that will take care of the long division when we're subtracting, I always bring down the first term. 2 times -1 is -2. 0 minus 2 is -2. 2 times -2 is -4. 5 minus 4 is 1. 2 times 1 is 2. -7 plus 2 is -5. So this one also does not go in evenly. But here we'll have no x's, x, x squared. It becomes our coefficients of the reduced polynomial. -x squared minus 2x plus 1 with the remainder of -5. Through your homework, you'll practice long division and synthetic division, so then we can move forward with the next part of the lesson to understand what we're going to do with these values using the remainder theorem and the factor theorem.